Formulas and junk art. What's up? Do you know how to find the area of an oblique triangle?
Yeah.
She took one of our HOA quizzes. It's like doing it each
Hey Tyler, what you got in the physics test?
So we talked about this a little bit yesterday. I think one of the homework questions came up about how you're going to find the area of a triangle. When you have an area of a triangle, you can use the sine value when you have the angle and the two sides next to it. So if you wanted to find the area of the triangle and you knew that this angle was 63 degrees and B was 17 and C was 12, I don't know, I'm just making stuff up. You can do that rather quickly by using one of those formulas. They're all the same. BC sine A, AB sine C, AC sine B. Just remember, all this means is that when you're doing the area of the triangle, I want you to think side angle side. Think side angle side. Yeah. All right. Think side angle side, and it's just going to be the angle, and it's two sides and the included angle, and that's what you would be using for any one of them. The letters just rotate. Okay. The letters just rotate. It's just a matter of the angle or the included angle with the two sides. Hopefully we have the calculators figured out now about switching to degree mode for all this stuff. Once we realize that you hit set as default, not OK. I realize you have to do it that way. It seems silly. And going from there. But yeah, this is just another one of those quick substitute in and go for it. Excuse me. If I'm not mistaken, one of the homework questions was that to start out with. I think there was one where it asked you to find the area. And didn't you ask that yesterday or 2 days ago? It's one of them. Oh, that's right, definitely. Somebody around here. So it's a relatively very easy thing to do. It's just a matter of substitution. So in this case, it would have been, 1/2, 17, 12, sine 63. Okay. Whatever that works out to be. The other ones that were in here when we're dealing with area stuff, I think I had that one next. I'll put that one. Is it this one? The other area formula is when it's called the Heron's area formula. It's a weird way of using. I think we might have touched on this last year in my Algebra 2 class. It's just a nasty formula if you just know the three side lengths. So if you know the three side lengths, for the area of a triangle when you have three sides, if you have the three sides, this is really ugly looking. What you have to do is, what's that? This is what's called Heron's formula. It's another way to find the area of a triangle if you just know only the three sides.
What if you find like base times height or something? Can you find that?
Yeah. You could, but the problem when you're finding a height, then you'd have to figure out how you're going to get the height out of one. This is basically if you're given the three sides like you would use log cosines for. You can find the area of that triangle, but you have to do one extra calculation. So if you have a triangle where and I'll draw up an example at the same time, probably easier to show you. You have to find what's called a semi-perimeter, and that's what they use that value S is called. So if I have a triangle, let's see, 43, 53, and 72. It's a really awesome looking triangle. If I have a triangle like that, the first thing I have to do is figure out what the value of S is. This value of S is called a semi-perimeter. So it's 72, 43, and 53 all over 2. So let's see, what was it? 96 and 72 would be 168. So you get 84 for this value of s. Okay. And then it's just a matter of substituting it. You take the area of the triangle then is going to be the square root of 84 times 84 minus 43, 84 minus 53, and 84 minus 72. It's not the world's easiest formula to use, but if you don't have that side angle side, you're just given the 3 side lengths, that's what you would use to find. So let's see here, I would do square root 84 parentheses 84 minus 43 parentheses 84 minus 53. Hey!
Plus 57 divided by 62.
That would be 110 divided by 62, which would be 55 over 31.
Yeah, I knew that.
0.2. I know, I'm sorry.
Sorry about yourself.
I'm sorry, Keck! You're gonna hate me.
He just know that it was him?
I don't know. Oh!
Chandler, why don't you ever have to go They don't talk to each other at all.
What does he go on?
Oh, I forgot to do tweets, not enough parentheses.
Goat?
Yeah, goat.
Like goats.
You don't like suspend you
Seriously,
after a while?
Float.
Don't you feel like
Goats.
So if you graduate, I believe it's not
You too, sir. 1131.89.
Wait, 1131.89?
Yeah.
Okay, that's what I got.
It's not dumb. It's correct.
Sorry.
Feel better about it? I understand, because I had to vent earlier also. So I get it. Every once in a while you gotta vent. So let's get to the other stuff that's kind of the weird part. When you have to use a bit of the bearings or how you read the word problem when you're dealing with law signs and or law cosines. So this one is, blow this up so you can read it better. The course for a boat race starts at point A and proceeds in the direction of south 52 degrees west to point B. Then the direction south 40 degrees east to point C. Finally back to point A. Point C lies 4 kilometers directly south of point A. Approximate the total distance of the course. So remember, when you're plotting these out, if you're starting at point A, and you're going to go south 52 degrees west, that means you are going, here's your south, and then your 52 degrees west. So here's your 52 to point B. From there it says you're going south 40 degrees east. And that's off the south here. And it says you are directly below A. So it's directly south of point A. Right? That's what this looks like. Excuse me. Remember, when you have the bearing problem like that with boats, it's going to be south or north, and then it's going to tell you to go east or west. So you're going to bounce off of that direction. So what we need to do is to figure out the total distance. Well, that means we have to figure out two other side lengths. Okay?
Right.
But it also means we need to figure out other angles. Well, figuring out the other angles really isn't all that difficult. It's just a matter of writing stuff out. Now, remember, one of the things that you can use here is that you've got two bearings that went south, okay? Last time I checked, south is parallel to south,
Yeah.
okay? So that means that these two values here are parallel to one another, okay? So I have two parallel lines cut by a transversal, which means what's this angle here? 40 degrees. So that's how you bump back into the triangle. So now you have 52 degrees, 40 degrees, and what's left on the inside?
88.
88. Good. Izzy, you look like you were very perplexed on that.
I don't like bearings.
Bearings make the wheels go around.
Very-
Sorry, that was bad.
You were taking a hard time to get that because,
Me too.
So what I'm going to do then is I use law of science twice. One to figure out the side length opposite the A, and one to figure out the side length that's opposite the 40. And that's about as crazy as some of these law of science ones are going to go, because you're dealing with north-south lines, and those are, north-south is parallel to one another. You might have a change of direction that you'll use the cut by a transversal where you get the alternate interior angles and so on through. Remember, when you're doing law of science, it's nothing more than cross multiplying. What?
sorry. Oh my God, good. What did he say? Did he make fun of me?
No.
Of course.
So you'll have 8 sine of 52 divided by the sine of 88 for one of them. Fraction bar. So I get 6.31 for this. Anybody else get that?
Yeah.
And then the other one will give 8, oops. Eight sine 40 over sine 88 again. And the other one I'm getting 5.15. Then you just add those up to get your total distance. Okay?
So you add 8?
Yeah, because it's asking to find the perimeter. It's like, what's the total distance of the race? The weird one of this is when they talk about when you have something leaning off of vertical. Okay. A pole tilts toward the sun at an 8-degree angle from the vertical, and it casts a 22-foot shadow. Find the angle of elevation from the tip of the shadow to the top of the pole. Oh, I'm sorry. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? So what you need to do here is draw a picture, which means you need a sun.
I thought he was about to go find it. That was like a sunflower.
You need the sun.
I don't
You should have put a picture
face
of
on
your
my
son.
paper.
That would have been funny. You need the ground.
It's boring. It's kind of boring.
Basically. A telephone pole. Does everybody know what one of those looks like? Okay. So if it goes straight up, that's vertical, correct?
Yeah.
Now, if it goes straight up vertical,
But 8 degrees off.
but it's 8 degrees off vertical towards the sun. So if my sun is this way, which way is it leaning? To
This way.
that way or that way?
This way.
That way. It's kind of a bad way of saying it, but so it's leaning off the vertical 8 degrees. So
How does it go?
if this is a 90-degree angle here, that means this is 8 degrees more. It's off of vertical by 8 degrees. The pole. It says it's leaning. If you're vertical, you're straight up and down. This says that it's leaning off vertical at 8 degrees towards the sun. I just have to draw the sun on this side, so it's just leaning that way 8 degrees. It then says that this is casting a shadow that's 22 feet long. Okay. And it has an angle from the tip of the shadow to the top of the pole at, what was it, 43 degrees. Okay. Alrighty. What are you trying to do? So now what we need to do is just figure out how tall the pole is going to be.
So you just drew this line.
We have to find that side, but we need to find some bit of information. So the only thing that we know right now, if we look at this, if I redraw the triangle, I know that this is 22, this is 43. If this angle was 90 plus 8, this angle is now 98. So in order to use the law of sines here, I just got to figure out that angle.
Right.
What's not right? Ah.
Can't you just
What's 98 and 43?
150? No.
141.
141. So what's left for up top then?
39.
And I need to figure out how tall the pole is. So I'm going to use the 39 to the 22. 43 is that side. The new part here really is to understand what it means to be off of vertical. It just means you're not at 90 degrees, you're tilted. You're the Leaning Tower of Pisa. Well, we could go to Niles, so they've got a replica over there.
That's the first thing.
Niles is a suburb of Chicago, and they have a replica of the Leaning Tower of Pisa in one of their city parks. Why not? Italian heritage. They also used to have a Maurice Linnell cookie factory there too. If you've never had a Maurice Linnell cookie, you've never lived.
That's like Garrett's popcorn. That's
Actually, they don't even make Maurice Linnells anymore, so. So then you wind up doing some cross multiplying, that's how you get this thing to work. Once you set up the law of sines, I'm not oversimplifying and thinking that it's pretty simple to go from there.
No.
Okay. That's those. The log cosine one can be a little bit almost as daunting at some point as well. So here's what we get. Why does there have to be a what? A ship travels 60 miles due east and then adjusts its course northward. After traveling 80 miles in that direction, the ship is 139 miles from the point of departure. Describe the bearing from point B to point C. U.
Yeah.
U. Okay. So they actually give you this picture, and what I want you to see when you're looking at it is basically you start, if you're going if this is your north-south, east-west, I think I just gave away which direction due east is.
Huh?
Alright, if you leave them, I don't want to cross
No.
Trying to prove one.
It went due east for 60 miles. Then adjusted its course northward. So it's going to go north from there. What direction on the whiteboard would it be pointing then? It would go up, but it just said northward. It doesn't tell you exactly where it was. So that's why they draw this picture. And some of the times you're going to get the actual picture itself. Okay. So they went due east for 60 miles. Then they went northward for 80. And then they knew that they were 139 miles away from where they started. So you wind up with 3 sides of a triangle. 60, 80, and 139. That is definitely not drawn to scale because that's a big bird. Okay. It wants you to describe the bearing of the angle from B to C. So we're going to figure out from there, if you're at point B, we know what it's going to look like right away. It moved this direction off of north. So if it was north and you went that way, is that going to be north something east or north something west? East. It'll be north something east. So we're going to figure out what that something is. Okay. So let's go ahead and do the law of cosines. Obviously, we need to do that to find which angle.
The middle one.
The middle one. Well, what if I'm standing like this? The middle one is across from the
Why
80.
not like the middle one and like the north
B. So we're going to use the law of cosines to find angle B. All right. So little b squared is a squared plus c squared minus 2ac cosine of angle B. So you fill in the blanks. And press buttons. So I'm there. Now I'm at a pretty straightforward 2-step equation. So I'll take the 19,321, subtract 10,000, hit enter. Divide that by negative 9,600 and hit enter. So right now I have, my calculator is leaving me in a fraction, it's not giving me a decimal. But I know that this fractional amount has to equal the cosine of angle B. It's a negative value, which means it's going to be an obtuse angle because it's going to put you in the second quadrant. So I hit my control trig, trig, cosine inverse of my answer, and then hit enter. 166.15. Yep. Okay. So now I have this angle is angle B. Right. Now, remember what the original picture looked like. You were going due east, and then you started going northward. Well, when you went due east, if I put in that next north line right there, doesn't that create a right angle?
Yeah.
So it creates a right angle here. So all I need to know to figure out what my bearing is off of north is what's left over from that right angle. All I have to do is subtract out the 90 degrees from that, and you get 76.15 degrees. So the bearing, because it's north, and then I came down 76.15 east, because I went to that side. Yes.
You say that like it's yeah, like you didn't get it.
We definitely don't have any time to do it tomorrow. No way. I'm not going to do it tomorrow. It'll just be something after break. Like the day we get back.
Like our actual test. They had to have the paper.
At this point, it'll probably just be a test over the whole chapter. Fontana and I were trying to see if we can get sine and cosines in this week and do something short tomorrow, so we didn't have to worry about remembering all this stuff. We'll just do another quiz later. But when Moose was sick, I just fell behind in the day, and I knew there was no way of getting caught back up. I didn't want to rush too much, so oh well. We gotta send you home to take on quiz.
No. That would be so hard.
I had a midterm. It was a take-home midterm in college. Awful. I know Severino gives a take-home test.
Yeah, he
Right?
does.
Yeah, he does.
My freshman year.
That was awful. That test is awful.
Yeah.
That circles one.
No,
Right.
I did really well on it,
Though.
because me, Colton, Jared,
Yeah, you guys can like work
like
together.
everybody worked on it together.
Everybody has one problem.
That's really all there is when it comes to the bearing stuff. When you're in these, remember I don't think there's any airplane ones. To be honest with you, I think everything's just. Oh, there's an airplane one.
No.
Right.
So if you're talking about an airplane, remember that's just however many degrees off of north, it just rotates itself through. Okay. What I'd like you guys to do is let's see, we have.
It's supposed to be 35 through 43 and 50.
I know that you guys had in 6-1 the word problems in 6-1. And then obviously we still have the word problems of 6-2. Why don't we try and get all the word problems for 6-1 done for tomorrow, and then we'll spend time in class working on the 6-2 word problems in class tomorrow, and try to knock it all out before we get out of here. Does that sound good? Whatever the word problems are left for 6-1, because I know we did a lot of it, just law of signs, the ambiguous cases and things like that, but we didn't do any of the other word problems yet. Yeah, whatever the word problems are that are left for 6-1, let's do those today. And then tomorrow in class we'll work on the 6-2 word problems, all right? And then that should knock out everything from 6-1, 6-2. I think that works. Wow, that's enthusiastic from you. So, well, sometimes.